Hello everyone, we are continuing our series of discussion of previous year's questions of UPSC CSC discipline geography, and today our aim is completing or finishing the climatology section, and we are moving forward in that direction only. So let's discuss our question number 2. Already one we have discussed today. So our question number 2: what causes the wind to deflect towards the left? Yes. What causes the wind to deflect toward the left in the southern hemisphere? So basically, we should have an idea that why wind deflect when it is moving in its path, flowing in its path, then it gets deflected in the southern hemisphere toward the left and towards the right in the northern hemisphere. So basically we are aware about this concept. This is only because of the rotation of the earth. Why? Because when the earth rotates, because of its rotation, we know a force which is known as the Coriolis force. This is given in our basic NCERTs. In basic textbook it is given that due to the Coriolis effect, all the winds or the objects move forward or move towards their right in the northern hemisphere and towards the left in the southern hemisphere with respect to the rotating of the earth. So because of the rotation of the earth on its axis, there is a force which is known as Coriolis force. This is given in our basic textbook, and it is also given that when any wind or any object is thrown into the atmosphere, into the sky, whether it is a space jet or whether it is any space vehicle or any rocket is launched, then this factor is taken into account, that if we are launching any spacecraft, any space vehicle, any rocket, then we should count this factor, that if we are launching it from the northern hemisphere or from the southern hemisphere, then in the northern hemisphere it will move towards the right, and in the southern hemisphere it will move towards a little left. So they consider it in their calculation and do some technical things so that they can launch their space vehicle according to their own goals. Thus in the northern hemisphere wind blow the counterclockwise along the center of low pressure, while clockwise in the southern hemisphere. So remember it, clockwise in the southern hemisphere and counterclockwise in the northern hemisphere, and the Coriolis force has zero effect on the equator. So, and while it is increased towards the pole. So we have some factual knowledge about the Coriolis force, that Coriolis force exists because of the rotation of the earth. Coriolis force is zero at the equator, and it starts increasing towards the pole, and it is counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. It moves the winds or the objects towards the right direction in the northern hemisphere, and we can also count in the right direction in the northern hemisphere and the left in the northern hemisphere, left in the southern hemisphere. So we already know the answer. It is because of the rotation of the earth. Now question number 3, that the jet aircraft fly very easily and smoothly in the lower stratosphere. So what is the appropriate reason for this? So here we should have some knowledge about the lower stratosphere, then we will only be able to answer this question. Let's read the options. That there are no clouds or water vapor in the lower stratosphere, and there is no vertical wind in the lower stratosphere. So basically it is telling us that there is no cloud and no vertical air wind flow, and this is the reason that jet aircraft or airplanes move very smoothly. So let's go for the answer. That stratosphere is preferred by the commercial airlines. Why? Because this stratosphere is free from the violent weather changes which occur below in the troposphere. So from this line we get a factual knowledge that all the weather phenomena take place where? In the troposphere, and these weather phenomena don't take place in stratosphere. So stratosphere is relatively very calm. There is no clouds and air is dry, there are very little water vapors, and obviously there is no vertical convection in the stratosphere, which means the air is not flowing, no vertical movement of air in this stratosphere. So because of its relative calmness, that no weather phenomena, no much water vapor, no vertical movement of the air, so this area is preferred as a area for flying the aeroplanes and aircraft. So let's have some information about the stratosphere. It is beyond troposphere, and it is up to the height of 50 km from the earth's surface, and the temperature in this layer remain constant for some distance. So temperature will be constant for some distance only, and then it will start increasing. It will rise from 0 degree Celsius at the 50 kilometer altitude. And why this increase in the temperature? Because of the presence of the ozone layer. So we get this information that ozone exists in the stratosphere, and this is the ozone layer which it absorbs the harmful ultraviolet radiations. This layer is almost free from clouds, yes, and also the associated weather phenomena, and it make it a ideal condition for the flying aeroplanes. So the airplanes fly in the lower stratosphere and sometimes in the upper troposphere where weather is calm. Sometimes cirrus clouds are present in the lower levels of this layer. So this is our question, that this is the stratosphere which is having the ozone layer. This is the stratosphere in which ozone, what it do? Harmful ultraviolet radiations are absorbed by it. It is relatively calm from any weather phenomena. There is no vertical movement of air. There is not so much water vapor available there, and because of it, the airplane prefer to fly there. So our answer will be both. That yes, no cloud, no water vapor, very less water vapor, or no vertical movement of the wind in the lower stratosphere. So our answer is C, both 1 and 2. Both the statements are correct and they justify the reason also. Now our next question is that a layer in the earth atmosphere called ionosphere facilitate the radio communication. Why? So we must have some a bit of information about the ionosphere and about the radio communication. So the reason is given that the presence of ozone causes the deflection of radio wave to the earth. So is it because of the ozone? We should have knowledge of this. And radio waves have a very long wavelength. Yes, this is a correct statement. We have done in our basic science books in the class 7th or 8th that the radio waves are having the longest wavelength. So we will move forward the answer of this. Ionosphere and how it impact the radio signal. Ionosphere is a region of the upper atmosphere. So first of all, ionosphere where? In upper atmosphere, where there are the large concentration of free ions and electrons. So large concentration of ions and electrons. While the ions give the ionosphere its name, but it is the free electrons that affect the radio waves and radio communication. So there is a free movement of electrons, and because of these free electrons, they affect radio wave and radio communication. In particular, the ionosphere is widely known for affecting the radio signals of the short wave radio bands, where it reflects the signal and enable these radio communication signal to be heard over the vast distances. So basically what this the layer of ionosphere do, it reflect the signals from our ground station. What we will do, for example, this is our ground, we will send some signals to this layer, and what this layer, because of the presence of huge electrons, it will deflect these signals and it will reach here. So what we are doing, that from this to this position we are sending these signals, these radio waves, with the help of the ionosphere. More explanation of this layer. This layer is located between 80 km and 1400 km, and it is electronically charged layer. So this ionosphere is electronically charged, and it is this free flow of electrons which deflect the radio waves. Okay, This layer is characterized by ionization of atoms. Because of the electric charge, radio wave transmitted from the earth are reflected back to the earth by this layer. So because of this electric charge, the deflection take place. Temperature again starts increasing with height because of the radiation from the sun. Obviously, as we move higher up in the atmosphere, we move towards more the sun and we get more radiation and temperature starts increasing because of this. So this is a basic information about the ionosphere, that this exists between the 80 kilometer to 400 kilometer electronically charged. Ionization of atom, because of this electric charge, when we transmit the radio waves, which are the longest waves in the electromagnetic spectrum. So these longest wave of electromagnetic spectrum, when they move and then they are deflected because of this electronic charge toward the other station on the atmosphere, and temperature increase in this layer because we are moving towards the sun. It is getting more and more radiation from the sun. Okay, and this is all our question. Now our next question, that consider the following which can be found in the ambient atmosphere. So basically, if we are in atmosphere, which kind of gases, which kind of particles we will get, this question is all about this. So the option 1 is soot, another is sulfur hexafluoride, and another is water vapor. Which of the above contribute to the warming of the atmosphere? So we have given the three options and we have to tell that above the three options which we are given, which is responsible for the warming up of the atmosphere. So let's move to the answer. The contributors to the warming up of the atmosphere. First of all, soot. It have the black carbon particulate matter, and what it does, it absorb the maximum amount of the solar radiations, insolation. It heat up any surface. So the soot is on a surface of any object. So what it will do, it will heat up the surface which it lie by. It will absorb the carbon dioxide and it will contribute to the global warming. So we can see that soot has an global warming potential because it absorbs the solar radiations and it heats up the environment. Sulfur hexafluoride, it is a greenhouse gas and it has having one of the highest global warming potential. Okay, water vapor is most abundant in the greenhouse gas in the atmosphere. So also water vapor also absorbs the radiation of the sun and heats up the environment. So as a greenhouse gas, the higher concentration of water vapor is able to absorb more thermal energy radiated from the earth, thus further warming the atmosphere. So it's not only this water vapor absorb the radiation from the sun, it also absorb the radiations from the earth, because during the day the earth is getting heated up from the incoming solar radiations, and these incoming solar radiations are of short wavelength. When earth heats up at the night, it radiates long wavelength radiations, and these long wavelength radiations are absorbed by the water vapor which is present in the atmosphere, and it heats up the environment. So the water vapor, whether it is a sulfur hexafluoride or it is soot, all these three having a global warming potential. It means they have the ability to heat up the environment. So we can also study what is greenhouse effect, because this question basically relate to that. The greenhouse gas are transparent to the incoming solar radiation. Yeah, this is one of the basic feature of greenhouse gases, that they are transparent to the incoming solar radiation. As I have told you, that these incoming solar radiations are of short wavelength. Okay, and some are opaque to the some wavelength of heat radiated from the earth. So basically, how does this phenomena take place? That we have a bunch of greenhouse gases. These greenhouse gases are transparent to the incoming solar radiation. They will not obstruct them. Okay, but when the earth gets heated up and earth radiates long wavelength radiation, these greenhouse gases will be opaque. They will not be transparent to them. They will not allow these long wavelength radiations to leave the atmosphere, to left the atmosphere. So these all long wavelength radiations will be into the atmosphere, will heats up the environment. Okay, so they trap the heat. Basically what they are doing, they're trapping the heat, and it eventually leading to the warming of the lower atmosphere, and this is called greenhouse effect. So we have some 2 or 3 factual knowledge. Greenhouse gases, first of all, transparent incoming solar radiation. They are opaque to the long wavelength radiation emitted from the earth. They trap the heat which is emitted from the earth, and this trapped heat lead to the warming up of the lower atmosphere. This phenomena is called greenhouse gas effect. The main source of man-made carbon pollution is the burning of fossil fuels, and it is about 70% responsible for the global greenhouse gas emissions. So basically we are done with the greenhouse gas effect, and the rest, yes, this is also, and the rest come from the deforestation, the livestock industry, and the agriculture. For each greenhouse gas there is a term. Global warming potential has been calculated, that it reflects how long it can remain into the atmosphere and how strongly it absorbs the energy. We have given 3 options to sulfur hexafluoride or a water vapor. So all these 3 elements, all these 3, they have different global warming potential. It's mean they will differently reflect these wavelength, these long wavelength radiations, and they will absorb different amount of energy. All these 3 elements which we are given, and all another greenhouse gases which exist in the which are present in the atmosphere, they all have different capacity to absorb the energy. So the gases which have the higher global warming potential, they absorb more energy, and what they will contribute more to the more warming of the earth, more warming of the atmosphere. So global warming potential shows the efficiency, not efficiency, capacity, basically the capacity to absorb more energy, the capacity to reflect, that how they will reflect into the atmosphere. So this is a term, and we are given the order of the most abundant greenhouse gases in the earth atmosphere is water vapor. They are most abundant order. First of all, the water vapor is most abundant, then the carbon dioxide, then methane, nitrous oxide, ozone, and chlorofluorocarbons. So it is according to their abundance. And now is methane is 25 times more effective in trapping the sun radiation in our atmosphere than the carbon dioxide, which is a dominant greenhouse gas. So basically it is an example to show us that what is a global warming potential, that methane is 25% more efficient, more effective in trapping the radiation of the sun, and leads to the more heating of the environment. We are given with a table also. This is a table, that this is a greenhouse gas: carbon dioxide, methane, nitrous oxide, chlorofluorocarbon 12, 11, hexafluorocarbon, and the sulfur hexafluoride. So these are the greenhouse gases, and they can sustain in our environment so many of years. For example, carbon dioxide has the ability that it can sustain in our atmosphere from 50 to 200 years, and its global warming potential is 1. And the global warming potential of sulfur hexafluoride is 23,900. So this sulfur hexafluoride is so much of having global warming potential. It means it will heat up the environment. It can sustain in the environment for a longer time, leads for around 3,200 years, and its global warming potential is huge. So this is all about global warming potential. Now our next question. A geographic region has the following distinct characteristics. So following the features and the characteristics are given, and we have to identify that the 4 options which are given, which of the following region having all features. So the features are like this: a warm and dry climate, okay, mild and wet winters, and another is evergreen oak trees. So we have to identify a region where we will find the warm dry climate, mild and wet winters. It's wet winters mean there is rainfall in the winter season, and there is evergreen oak trees. So our answer will be, this is a Mediterranean climate. So you know that all the questions that we have discussed in our series, we have find that we must have a knowledge about the seasons, about the reasons, that what kind of atmosphere, what kind of rainfall, and what kind of the forest they have. Mediterranean climate is characterized by the mild and wet winter season. It's mean the winters will be mild and they will be wet. There will be the rainfall in the winter season. The citrus fruits like the oranges and the grapes are grown in these regions. Evergreen oak trees are one of the important features of this type of climate. Okay, so in Mediterranean type of climate, we will find mild and wet winters, citrus fruits like grapes, and even the oak trees. Mediterranean climate is found between the 30° north and 45° north latitude. It's been between the 30 and 45° north latitude. This climate, so it is only given in the north, not in the southern latitude, mind it. This climate is often found on the western side of the continent. The Mediterranean climate gets its name from the climate found around the Mediterranean Sea. The climate is known for warm to hot, dry summers, mild to cool, wet winters. So the summers will be hot and dry, winters will be mild and wet. So this is the, and even we have given a, let's have some more information. Entirely confined to the western portion of the continental masses. So this is the Mediterranean climate, and where we will find it? In the western portion of the continental masses, on the western side. Okay, and where 30°, 40° north and south of the equator. It means both side of the equator. So we will find this Mediterranean type of climate between the 30° and 45° in between, north of the equator and south of the equator. The basic cause of this type of climate is the shifting of the wind belt. Obviously, most of the weather phenomena which take place because of the shifting of the wind belts. Mediterranean Sea has the greatest extent of this type of winter rain climate. So in the Mediterranean Sea, we will find a distinct feature that rain takes place, rain comes in the winter season and give rise to the Mediterranean type of climate. The best developed form of this type of climate in the central Chile. Other Mediterranean regions include the California, the southwestern tip of Africa, and the southern Australia, and the southwest Australia also. And we have given this pic also, that is, it is on the western side. This is on the western side of the continent, and this is above the equator. This is our equator, above the equator and below the equator also. So these are the features of the Mediterranean type of climates. Yes, our answer. So from this particular question what we get, that we should have idea that which geographic region of the world have which kind of climate. Okay, so this question is not the end in itself. This question is giving us an indication that in which way we should prepare. From our NCERTs to basic standard books, we should cover all types of climate which exist. Now our question number 7. Yes. Which one of the following reflect back more sunlight as compared to the other three? So reflection of the sunlight, it means sunlight is falling on an object and how much it is able to reflect back that sunlight into the atmosphere. Okay, and what this phenomena is known as? From our basic NCERT we find this phenomena is known as albedo. So albedo is the portion of the solar energy. It is reflected from the surface of the earth back into the space. It is reflection coefficient and has a value of less than 1. Land covered with fresh snow reflect maximum sunlight as compared to the rest of the three because it has the maximum albedo. So basically, as the sunlight enter into our atmosphere, some of the sunlight reflected from the clouds itself, some of the sunlight enter into our atmosphere, some portion, some is reflected into the space back, and some portion which it enter into our atmosphere, then it is reflected from the objects, from the sand, whether it is a snow. So this reflection capacity, this reflection coefficient, so every object have different reflection capacity or different reflection coefficient. So basically the snow having the maximum reflection capacity, it means snow having the maximum albedo. So our answer will be C, that land covered with fresh snow having the maximum capacity to reflect the sunlight back, albedo. So let's more detail. A body or a surface reflect a fraction of light, which is called albedo. There are two type of albedo, terrestrial and astronomical. The normal albedo is called normal reflectance, a measure of a surface relative brightness when illuminated and observed vertically. Albedo is a portion of sun energy reflected from the surface of the earth back into the space. When the solar radiation passes through the atmosphere, a certain amount of it is scattered, reflected and absorbed. The reflected sum of radiation is called albedo. This is reflected. Some is scattered, some is reflected, some is observed. So this reflected portion is known as albedo. Albedo and the global warming. The difference in the average albedo of earth has an important influence on the temperature of the earth. So basically this is a phenomena. This is a climatological phenomena, and this has its bearing on the temperature of the earth also. If the average albedo is lower than the previous year albedo, it specifies that the amount of radiation absorbed is higher. Basically, if albedo is basically the reflection, more albedo, more reflected sunlight, reflected back into the space. Okay, but less albedo, it's mean lower albedo, it's mean more of energy is absorbed. And if more of energy is absorbed, it's mean the higher temperature of the earth. Earth albedo is constantly measured using the satellite to monitor the warming, global warming. So basically this phenomena, this climatological phenomena help us to know that whether the temperature of the earth will increase or decrease. So basically this help us. So these are the questions which we have discussed. Now only one video will be more there about the geography questions related to the climatology section of the prelims 2020. We have discussed all the questions from 2011 to 2019 related to the climatology section, and now only one more video about the climatology. Only two questions from the prelims 2020 which were related to the climatology section, and this is all which we have done.